Hey guys, welcome to another video. So today I'll be sharing with you how to solve this complicated algebraic problem. And it's not so complicated if you really take time to understand it. So the question is, if x minus a times x minus b equals to 1 and a minus b plus phi equals to 0, then what is x minus a the whole cube minus 1 over x minus a the whole cube? So we have to dissect this question and use the two given equations to help us make important substitutions to find out the ultimate answer. Now from the second equation, a minus b equals to negative phi, we can change it to b minus a equals to phi. So we can use the x minus a in this case, that two variables x minus a and x minus b, you subtract both. X minus a minus x minus b equals to phi. Since there's a minus, the both x terms will cancel out, and negative a plus b equals to phi, which we already know that b minus a equals to phi. So now we'll use that during substitution. Now we take the first equation and we get x minus b as a subject of formula. So x minus b, using it as a subject of formula, equals to 1 over x minus a, since you divide x minus a from both sides. So now you take the first derived equation, x minus a minus x minus b equals to phi. We'll substitute x minus b as 1 over x minus a. So it becomes x minus a minus 1 over x minus a equals to phi. So now, to make things more easier, we'll use a simpler term to substitute it and to solve equations and to solve back x minus a. So we substitute x minus a as y. We let y equals to x minus a. So y minus 1 over y equals to phi. Now the question asks for y cube minus 1 over y cube, which is x minus a the whole cube minus 1 over x minus a the whole cube. So now the golden rule of mathematics is, if you do not know the value of something, substitute it as a algebraic term or a variable. So in this case we'll put it as z. Is the funny golden rule of mathematics. So now the answer that we're looking for is z. So now we'll apply the difference of cubes formula, in which states that x cubed minus y cubed equals to x minus y, x squared plus xy plus y squared. So in this case, y cubed minus 1 over y cubed equals to y cubed minus 1 over y the whole cube. So this can be applied as difference of cube formula, in which y cubed minus 1 over y cubed equals to y minus 1 over y times y squared plus 1 over y squared. How we get the 1 is you multiply y cubed times 1 over y cubed, which is 1. And which is 1, and you multiply 2, and 1 is x times y, which gives you 1. So we already know that y minus 1 over phi equals to y. So y minus 1 over y square equals to phi square, which is 25. So now y square minus 2 plus 1 over y square, we have expanded the parenthesis. This is the expanded form. So how do you get negative 2 is that you multiply 2 times y times 1 over y. So negative 1 over y times y equals negative 1, and you multiply 2 by it, so it becomes negative 2. So y square minus 2 plus 1 over y square equals 25. So y square plus 1 over y, to get what we need, equals to 25 plus 2. You add 2 to both sides, which is 27. So we already know that y square plus 1 over y square equals 27, and we have to use the y cube minus 1 over y cube difference of cubes formula to substitute in the values and solve for the answer. Y minus 1 over y equals to 5, and in the second parenthesis, y square plus 1 over y square equals 27 plus the extra 1 over there. So y cube minus 1 over y cube equals to 5 times 27 plus 1, which is z equals to 5 times 28, and z equals to 140. Now in this case, you do not really have to go back to x minus a. It's just substitution of y, and almost for more than half of the question we didn't even touch on x minus a or x minus b or any of the a, b variables. So because the question just asks for x minus a itself, which is y, and related to y, that's why we only have to solve for z and not have to go and refer back to x minus a or x minus b and use it for the remaining solutions, remaining equations and remaining steps for the question. So answer is z equals to 140, so which is option C. I've adopted this problem from the internet, from SSC CGL Solution Set Algebra. You can go to suresolve.com to find out a more detailed solution and to have another solution at this question. And thank you once again for watching my video. Please press the like button, please subscribe to our channel, and please share this video with others whom you think this video is useful for. Thank you.